Carter's doomsday is a mathematical argument that claims to predict the end of the world. The fundamental idea that powers this argument is quite simple. Now let's consider two boxes containing numbered balls. The first box contains only 10 balls numbered 1 through 10, whereas the second box contains 10,000 balls numbered 1 through 10,000. Now suppose you are handed a ball numbered 2 and told that the ball was taken from one of the two boxes. Which box would you think the ball came from? It seems that it is far likelier for the ball to have come from the box with just 10 balls, right? Now let us extend this idea to the Earth. Assume that there are two identical Earths with one that would support life up to the 200 billionth human, after which the world will end, a near doomsday, and the second Earth allowing up to 200 trillionth human, a far doomsday. Now given that you are amongst the first 100 billion humans alive, which Earth do you think you would belong to? Similar to the first example, it would seem that near doom scenario is much likelier. But by how much? To calculate this, we can use Bayes' theorem. Now consider the two scenarios, near doom, denoted N, where the world will end after 200 billion humans, and far doom, denoted F, where the world will end after 200 trillion humans. If we're given no further information about these scenarios, the probability of these two events would be 50-50. We can set this as our original belief. Bayes' theorem allows us to update our beliefs in light of new evidence. Now let's consider the evidence that we are amongst the first 100 billion humans alive. The probability that we are amongst the first 100 billion humans, given that only 200 billion humans will ever exist, is simply 1/2. Similarly, the probability that we are amongst the first billion humans, given that 200 trillion humans will exist, is 1 in 2,000. Now if we plug these values into Bayes' theorem, we get the probability that the world will end after 200 billion humans are born to be 1,000/1,001, or 99.9%. Assuming the current birth rates will continue, this theorem suggests that the world is 99.9% likely to end within the next 1,000 years. This argument seems to be scarily convincing, but should we accept it as fact? Should we start bracing for a mathematically prophesied apocalypse within this millennium? Well, maybe not just yet. Carter's doomsday is subject to intense mathematical debate with dozens of papers disputing the claim and dozens of papers disputing the disputes to the claim. So let's not spend too much time worrying about the end of the world. Rather, let's spend time coming up with other weird ways to apply mathematical ideas.